All right, so I'm talking about clean code today, and again, there are two things that really make a difference between a beginning engineer and a seasoned engineer. And I want you to be seasoned engineers from the day you start. And and people will notice this. Your colleagues will notice. Certainly I did. I could always tell when I was reviewing code from somebody who was starting versus somebody who was more senior. And the two things that were the most important to me, that made the biggest difference, I should say, well, they are important, but the things that made the biggest difference in how I thought about the person who wrote the code to me, number one was error handling. Make sure every single error, every single exception is caught, reported to the user, taken care of, and that the system continues to run and react properly when the error happens. And number two was the quality of the cleanliness of the code. And that's the things I'm going to talk about here is about code cleanliness. Now, when I was at Google, the other thing that makes this a big important topic for me, Google has what they call a readability program. When Google was first founded, the first engineer that worked there that they hired was named Craig Silverstein. And he was a phenomenal developer, wrote much of what how Google still works and a lot of that. When he would hire new engineers onto the team, he had a policy that he would sit down with them for 2 weeks and they would do pair programming for 2 weeks. And then at the end of those 2 weeks, if he felt like that they were writing good enough code that they could write on their own, he'd give them permission to go off and do on their own. They were not allowed to submit any code to the repository unless they did it in that pair programming session. If he wasn't happy with them after 2 weeks, he'd fire him. So after 2 weeks, he made sure that they were doing all right. He did this for the first many hundreds of engineers that were hired went through this process with him. And of course, as Google went to thousands and tens of thousands of engineers, he couldn't keep it up. And so instead they developed what they called the readability program. And it was the same idea. You had to prove to somebody at Google that your code was high quality and that you knew how to write high quality code. So when you go to Google, if you are already at Google and you switch languages, or if you are hired into Google, it doesn't matter how senior you are, you can have 30 years of experience and you still have to go through this process. You come to Google, you do not have permission to submit any code to the repo until you have gone through this process. And so in this process, you work with a team of what we call the readability reviewers, and they would look over your code over and over and over again, and they would verify that yes, we think that your code is high enough quality that you are now allowed to submit code to our repo. And after I'd been at Google for a couple of years, I was invited to join the readability team, and I worked on that for quite a while. And then after a number of years, I actually ran on the Java team. I actually ran the Java readability program Google-wide. And I did that for 3 or 4 years until I decided to step aside and let somebody else have the experience. So in that process, I learned a tremendous amount about how to write good, clean code, and I developed an even stronger love and appreciation for writing good code. So what I've done in this is I thought, well, I'm going to talk about how to do that. Now, at Google, we said there are 3 aspects to clean code. Even though it was called the readability program, we were testing all 3 of these things in your code to make sure it was well written. The first one we call readability. That means if I am looking at your code, can I figure out what it does? If I'm reading your code, that's readability. Testability means how hard is it to write unit tests? We've done a little bit of unit testing, and as I said, unit testing had the biggest impact on me as a software developer in the course of my entire career. Given all the different things that I lived through, all the changes that happened, unit testing was by far the biggest impactor on my code, how I write it, how I think about it. And it's surprisingly easy to write code that can't be tested. And so testability was a big issue. And then the other one was maintainability. Maintainability means basically, if I need to make changes to the code, how hard is it to make those changes? If I have to add a feature, how many different places in the code do I have to make those changes? Just to give you an example of a badly maintainable piece of code, I took over some code for a friend who was having it being developed out of the country, and it was not going very well. So I had him get the code from them and give it to me. And I decided to make a few changes to the code and see what I wanted to do. I wanted to do a very simple change, which basically ended up adding an if-else statement in somewhere to check another value that I introduced. And so I made that change and went and tried to find all the other places I had to do it. And there were so many, I started counting them, and I got to 60. 60 different places in the code that I had to change in order to add that feature. That code was not maintainable. It was some of the worst written code I'd ever encountered, by the way. So, that's maintainability. So those are the things that are really, really critical to writing your code so that you look like you know what you're doing, and so that your code is actually really usable. In this presentation, I'm only going to talk about readability. The others, take me hours to talk about all of them, so I'm going to focus on readability right now. Why is readability important? Why does it matter if somebody can read your code? Any thoughts?
So we can do pair programming.
So you can do pair programming? How many times do you write your code?
We read it more than
We write it once. How many times does your code get read? Yeah, hundreds of times, literally hundreds of times. If your code goes up into the repo, it'll probably get read by someone hundreds of times. And one of those times it's going to be you, maybe 3 or 6 or 9 months later. And if you look at the code and you think, what was I thinking? I can't figure out this code. There's a problem. And you know that if you can't figure it out, then some other guy who's going to have to go in and make the changes is also not going to be able to understand it. So making your code understandable is critical. If you actually ask, what do software developers do most of the time? It's surprisingly uncommon for a software developer to write new code. We actually call it a greenfield project, because it happens so rarely. It's nice and green, it's starting from fresh, and you get to go in and write new code. It's not something you do very often. You spend most of your time enhancing, maintaining, modifying, improving existing code. So those are the things you spend most of your time working on, existing code. So if that code's not readable, then you're in trouble. So readability is absolutely critical. And so these are some things that will help you with making sure that your code is readable and understandable. You really won't learn how to write very, very readable, understandable code till you've written tons of it, and you had lots of people review it and tell you, I don't understand this, and so on. So it takes time, but here's some things that I'm going through, some of the main things that will help you out. Just as a note, when I review code, I don't start reading it from the top down and reading it in detail. Instead, I scan through the code, and I just kind of scan it. And usually, if code is well written, I can scan it and I can get a very good idea of what it is the code does when I just scan it, just from the way that it's laid out and the function names. And I can say, oh, there are loops here and there are loops here, and what is this function doing? And I just do that scan and I get a good sense for it. And once I then have a good sense for what it's doing, then I can go in and start reading in detail in each of the different functions and look at it in more detail. So you just keep that in mind as you're writing your code. Make sure your code is well enough structured. Functions come in an order that makes sense. The code does things that seem logical, and you're commenting and documenting where it is you need to put stuff, and that your code flows well, so that as someone scans your code, they can get a good sense for what it's doing. All right, that said, let me go on to some of these suggestions. First of all, formatting. Now, when I was at Google, they did not have automatic formatters. when a member of my team got tired with that and he tried writing one, I believe it was the first attempt at, well, not the very first attempt in the world, but it was the first attempt at Google to write a formatter. He got pretty close, and then we turned it over to the Java core team, and they completed it. I don't know if that has any relationship to Prettier. It was written in Java. I don't know what Prettier is written in, but Prettier recently has come up, and it does all of your formatting for you. And you may or may not like what Prettier does. Prettier has adopted the attitude. They used to have tons and tons of options on how to do the formatting like you want. Over time, they've come to the realization that if everything is formatted the same, then it's readable by everybody, and you just get used to their rules and you follow them. So nowadays, you let Prettier do your formatting. You take what it says, and that's it. So you let your Prettier format all the time. Usually, you'll set up your IDE so that it formats on save. And so you're always getting your code formatted properly, and you don't have to worry about it and think about it. Formatting is something we no longer have to worry about or think about. And if you don't like what it does, tough. So that's the attitude they've taken. There's very, very little you can configure in Prettier anymore, and you just have to learn to like what they do.
So I followed Dennis Ritchie.
All right. Next one, naming. The most important thing you can do to making your code readable is naming. So what does it take to make your code good and to find a good name? It's surprisingly challenging. I can think of many times where I've been writing along my code in a good flow, and I have to name a function or an object, and suddenly I go, I don't know what to name this. I can't think of a name. I better come with something and then just go on. No, that doesn't feel right. And I stop. And I have actually literally had experiences where I sat there for many, many minutes, 5, even 10 minutes, trying to come up with a name. And sometimes I'll come up with one after several minutes and I'll go on. But I've also had the experience where I could not come up with a name that I felt was appropriate for what I was trying to do. And that made me step back and think, if I can't think of a name, maybe I'm doing something wrong. And I have actually gone back and redone my implementation and my approach for how I'm going to do something because I could not think of a good way to name what I was working on. So naming is incredibly important. Your names have to express what it is you're doing with your code and avoid confusing the reader. Okay. All right, so here's some practices that I've put together for doing good names. These are ones we enforced at Google, and they are, there's a lot more to the naming, but these are just ones that struck me as the most important ones. Okay, so if you follow these, you'll be a good way there. So first of all, you're going to come up with naming conventions. For example, I want to name something, the number of chapters in a book. So I'll have a variable called the number of chapters, or that refers to the number of chapters. Am I going to say num chapters, or am I going to say chapter count? Am I going to say NO chapters, because NO is a common abbreviation for number? You probably won't do that, because if you say no chapters, people will be confused. But, do you spell it out? Number chapters, number of chapters. What do you do? Doesn't matter. It's a choice. It's a choice you have to make. Once you come up with a choice, use it consistently all throughout all of your code. And probably things like that for those types of naming conventions, you're going to have conventions that are established in your company, and they'll be in a style guide somewhere. At least that's what we had at Google. Is we had a big style guide that had all these types of conventions and things in it that we were required to follow. Had little things like if your function has an acronym in it, like HTML, do you put all uppercase HTML, or what do you do? And our convention was you start the uppercase letter and then everything is lowercase, even if it's an acronym. So, just things like that. Doesn't matter what you choose, just be consistent. Yeah.
I was just wondering how long should the names be?
I'll get to that.
Sorry.
Okay, I'll get to that. all I'm saying right here first is make your naming come up with conventions and be consistent. Yeah.
Sorry, what do you mean by conventions? Like you come.
Like,
with-
am I gonna say book chapters? Am I
And-
gonna say chapter number of chapters? Whatever.
Oh,
You come up with a convention, which is, this is what we're gonna follow, and we're gonna use that everywhere. Okay, it's always gonna be NUM, uppercase, whatever it is that it's counting, for example. Or, chapter count, this is what we're going to do, and this is our convention, and that's what we're gonna follow when we do it. Okay? All right. Next, name should be descriptive, but brief. There was a trend for a while, probably a decade or more ago, where people started making very, very long descriptive function names. So I would see function names like read the book from the database and throw if not there.
oh,
Not now.
that's like
Okay?
one sentence.
That was the name of the function. And they would be like these really, really long functions. And that was quite the trend for a while, until we started to realize that it made your code way too long. It would have to wrap around to fit in the line. But worst of all, it's very hard to read. As you're reading along and you see a function, you have to stop and read that whole thing in order to understand what it is. So the cognitive load on the reader was very high. It was very difficult to deal with. So you need to be brief. Okay. So how brief? One letter is probably too brief, but you need to be both descriptive, long enough to be descriptive, but brief. So in that case, read, here's one. I actually got this one. Read from database book and so on. These are too long. You don't really need all that information in order to figure out what's going on. So, but if you do names, so that's it. Be descriptive but brief, and make them descriptive. So here's one though. If they are descriptive, this is certainly descriptive. Read from database chapter. Read from database book. The problem with these ones is you want your names to be distinctive in the first few letters, because if somebody is reading your code, they're going to notice those first few letters, and then they're probably going to scan to the end, to the rest of it. That's just the way we are when we read. And so it's going to take me, I'm going to have to read this and go, oh, wait a minute. Oh, it's the chapter. This one's the chapter. This one's the book. And it takes a lot of cognitive load and attention in order to get and realize which one's reading the book and which one's reading the chapter. So what you want to do is you want to flip it around so that it's distinctive in the first few letters. Read book from database is much easier to grasp and read chapter from database. These are much easier to grasp because the distinction here, chapter and book, shows up very quickly. And then you probably really don't even need to say from the database. That's probably obvious. I mean, it's possible it's not obvious, but it's probably obvious from your context. So probably just read book and read chapter would be the best names there. Okay.
Oh, I'm sorry to interrupt, but are you going to talk about CSS naming and?
Nope. This is all in code. I'm not talking about CSS naming and HTML naming and everything here. I don't actually know what the conventions are there, how to make that code more readable. So my expertise is in code, not in HTML, CSS. Okay. So, all right. All right. So now there's some conventions that have been forced upon us by years and years of writing code. Variable and function names in JavaScript should use camel case, lower camel case, start with the lowercase and then use the uppercase C. In other languages, it's different. Like in Python, they like underscores all over the place. In C#, they like to start with the uppercase letter, but in JavaScript, we use lower camel case like this. When you're doing a global constant, it's common to see upper snake case where everything's uppercase with the underscores. This actually comes about starts with C. So in the 1950s and 60s, this convention was developed. You'll see it all over the place. I personally don't really like it, and I'm starting to see a lot more code that doesn't use it. I find it kind of hard to read and deal with. And so now if you just use camel case a lot for your global constants, you're fine. So it's kind of it's just a choice. Okay. but you'll see this a lot in because of it's been around for 50 or 60 years. Okay. All right. Now I'm doing a variable and I want to name my variable. A variable usually describes what?
An action.
No. Variables don't describe actions. Variables describe
Values.
things. Yeah, values, things. They describe things. So because they describe things, they should be a noun. Most of the time, your variable name should be a noun or an adjective that describes the thing that you're doing. For example, num books. Num is bad because you don't know what it is it's describing. But num books, number of books is a good one. But it's a noun or a noun phrase that's describing the thing. Okay. All right. You will often have variables that hold. Sorry. Out of different order than I was expecting. The next one, I say that your variable names don't usually encode the type of the thing it's holding. That also was in vogue for a while. So you would often see something like name stir, num books number, and so on. And you'd see these all over the place. You know, name object or whatever, book obj. And so it would encode the type. The problem with this is that, again, it's just noise. And so it makes it harder to read. It's noise because as IDEs have gotten better, usually your functions and things are short and you can tell what they are just in context. And if you change your mind and change it from a string to a number, then you're going to have to go and rename everything. That's a pain. So if you just call it name, and then also in an IDE, usually you can just hover your cursor over the variable and it will tell you what type it is. So we've decided that these type qualifiers here on your names are noise and they're no longer preferred. Occasionally you need them, but most of the time you don't. For example, for references in React, we often put ref after it. All right, sometimes you'll have a variable that is a Boolean that will try to describe the state of something, you know, and like, is this book open? Is this book closed? And so on like that. And so that's what your variable is holding. And so Boolean variables, we would like to have start with is or has. So is open is usually what you will do when you name these things. That's better than open. Open is it an action, a state. So it's just become convention to put the word is in front of all your Boolean variables. And then again, it makes your code more readable. So we'll do that. All right, so that's some ideas on variables. What about functions? What do functions describe? They're actions. Yeah, a function tells, it's an action. I call a function because I want it to do something. That's why I call a function. And so functions are usually verbs or verb phrases. Okay. So for example, I'm going to want to, if I have a function that's going to read a book, I'm going to want to call it maybe like read book. So it's a verb or a verb phrase. And that way it's very clear when you read it what it is, and it makes your code more clear and understandable for what it's doing. Okay. Let's do some, the last one that I've identified here is module names. Remember what a module is in JavaScript? What's a module?
It's a
File.
A file. A module in JavaScript is a file. That's not true in all languages. In Java, a module can be a collection of files. A file actually is a class name. There's a class, holds a class. So in C++ and C, modules, the concept doesn't really exist. So modules are nice things for organizing your code. In JavaScript, it's a file. So what this is really saying is when you name your files, what we usually like to do for file names or module names in JavaScript is use all lowercase or kebab case, and then they should indicate the category of the items that they hold. So you want to make sure everything in your module is all related to the same purpose. Okay, and then you name that module using lowercase or kebab case, depending on what your company convention is or personal convention is. All right.
Is it just question? Is it the the module is kind of component too, right? It's a component of a big.
Well, we're talking about React. So let me talk about that. So anyway, these are the conventions that we use when we're writing in our TypeScript code and just writing code in general, unless we're working in React. Now, React violates numerous of our naming conventions. And so you kind of have to say, okay, wait, this is a React component. So I have to follow their conventions instead of the normal TypeScript conventions. So I just listed some of the things that React breaks when it comes to the conventions that we normally follow. For example, a React component is a function, but you have to use upper camel case instead of lower camel case for a React component function. So that's one place where it violates it. Then also React components, they don't describe actions, they describe things, something that's going to sit on your screen, a thing that's on the book or on the page. And so they have to be nouns, or they typically are nouns. I would say always. React component function names are nouns, and they describe whatever it is that's on the page. So for example, book details, it's a noun. Okay. And then modules when you have a React component that exports a React component, usually you want the file name to exactly 100% match the name of the component that it exports. And so if you have a book details component, then the file will be bookdetails.tsx or JSX, whatever depending on what you're writing. Okay. So no, you don't do it lowercase, you don't do it kebab case, you just always all uppercase or upper camel case, exactly the same as the function name. Okay, these are just some of the conventions that I teach all these great ways to write readable code, and then we're saying, well, but in React we don't do that, and that's right. In React you don't do that. In React you break several of the rules here, and that's okay. It works well in React, and it's just things you have to remember. Okay, let's move on to function and file length. I'm not going to show the answers here. So how long should a function be?
Is it doing one functionality? Sure.
Okay, doing one functionality. That is very important. That's actually critical. A function should do one thing and one thing alone. And it's funny, I went to dinner with my granddaughter last night, and we were chatting about a bug that she was working on at work. And after she described it all and what they did to fix it, I said, oh, so you mean you had one function that was doing too many things? And yes, that was what the problem was. And so I suggested that she break it into 4 different functions. What? 4 functions instead of 1? Yes. For readability and maintainability and stability, you need to do that. So functions do exactly one thing. So, okay, so I have a function does one thing. How long should it be? Let me ask it in a way that might be easier. How long is too long? Is 1,000 lines too long?
Yes.
Is 100 lines too long?
No.
Is 20 lines too long? Is 2 lines too long?
Yes.
Okay. 2 lines. I actually had one of the Java readability captain that I took over from told me, he said, if a function has 5 lines of code in it, it can be too long if it's doing 2 different things. So, this is not a strict rule, but generally as a rule of thumb, if your functions are more than 15 or 20 lines long, they're too long. Okay. And then unless you're writing React, and I'll get back to that. But your functions should be, if it's 15 or 20 lines of code, it's too long. And so usually it's going to be too hard to figure out. The easiest rule of thumb is that your function, the entire function should fit in one page on your screen. So if you're doing on a laptop, that gives you about this much space. You'll see a lot of developers have the big monitors, and they'll flip them horizontal or vertical like this. And they do that so they can write longer functions and get the entire function on one screen. But that's your rule, is it should all fit on one screen, because you want to be able to go down and scan it and understand that entire code without having to scroll. Okay. And that is typically about 15 to 20 lines. They, of course, occasionally will get longer. What about files? When is a file too long?
When it has things that don't belong in the category it's supposed to contain.
Okay, same idea. Everything in the file should be focused around one unit of one thing of work that it's trying to do, one concept. But still, okay, so I've done that. Now my file is 1,000 lines. Is that too long?
Yes.
Probably. How about 500 lines? 200 lines, 100 lines. So files don't need to all fit on your screen. So usually we go 200, maybe 400 lines of code is the rule of thumb for that. Yes.
Yeah, this is pretty much what caused the confusion for me. So you said the module name or the component name has to be a noun, like describing.
If it's React.
Describing thing on the, and inside it probably has like a variable which
Let
is
me talk
noun.
about React in a second. So React violates a lot of these conventions. And so with React, you'll actually write much longer functions and much longer files. Okay. So this is just in normal. These are normal rules of thumb. So here, let me make sure I got everything in here. 20 to 30 lines. Okay, I said 50 to 20. Here it says 20 to 30. React, and then note that React functions often get a lot longer than this. And the problem with React functions is you have all this JSX, then you have all of these handler functions. And so your component function can easily get to a couple of 100 lines of code. I find even that too long, so I'll often will break up a large, if I have a component function that's 200 lines of code, I'll usually break it up into smaller components so that I keep it short. But they do tend to get longer. But then if I have handler functions, I'll make those handler functions just be 3 or 4 or 5 lines of code. And if they start to get longer, I'll break them up and I'll extract those into a function that I put somewhere else to keep them kind of short. But the React component functions do get longer. Okay. If your function is too long, I have 100 lines of code in my function. What do I do about it? It needs that much code in order to get things done.
You need to cut it up in sections.
You break it down into functions, into smaller functions. So it's a lot easier to read a single function that makes 4 other function calls, and you go, oh, okay, it's going to do this, then it's going to do that, then it's going to do that. And then I go read each of those functions and make sure that they're doing the right thing. So that's much, much more readable than a single function that's 100 lines of code. Okay. So break it up into smaller ones. Why do we write functions? We write functions. Usually people say we write functions so that we can make our code reusable. I have a little piece of code that I want to do multiple times, and so I make it for reusability or dry, right? Do not repeat yourself. So I don't want to, so I'm doing that. In this case, I'm telling you to break it up into functions, even if those other functions will only be called once. So just keep that in mind. Sometimes you use functions to make your code more readable, not just for reusability, but also to make your code more readable. Okay. Okay. Then 200 lines here. And again, with React, it's not uncommon to have much longer React component files, because React just gets kind of verbose with all the HTML inside of it. Okay. So I want to tell a story here. I was working at Google, and I was working on something where I had to go and make a change to the Google search code. I had to add a switch that I wanted it to do special case handling on. So I didn't work in the Google search team. I contacted the Google search team and I said, okay, what do I have to do? This is what I'm trying to accomplish. What do I do? I got an answer back. It said, go to this file and then add a switch case. Okay. I said, okay, I'll do that. And then of course at Google, once I did that, I sent it back to them. and they review it, and then it only gets pushed into the repo if they approve it. Okay, so I opened up the file. It took 15 or 20 seconds for the file to even open in my IDE because it was over 4,000 lines long. Then I said, okay, fine, I got it here. Scrolls real slow, but it's there. And then I said, okay, where's the function? I discovered that there was one function in the file.
No,
That function was 4,000 lines long.
no.
And so I said, oh no, I had to scroll through 4,000 lines of code trying to understand what's going on and figuring out where I should insert my case statement. And I finally found it. I inserted it. I added 2 lines of code. Okay. Bundled it back up. Sent it back for review with a snide comment about gee, this is really long. It should be broken up into smaller chunks. You know what answer I got?
No.
We all agree with you. But this code is executed millions of times per second. If we mess up that code, Google breaks.
Oh,
Nobody is brave enough to go in and break that into smaller chunks. Okay. So sometimes code as it evolves gets longer. Usually code starts out nice and short and clean, and then it evolves and evolves and evolves and evolves, and it just gets longer and longer and longer. So anyway, that was an interesting experience.
The application, if it's too long.
It can reload. Usually the code's well tested. Certainly that was. It executed millions of times a second. We know that code worked. But usually if a function is too long, it makes maintenance a nightmare and testability a nightmare. So that was what I was facing there. Okay. All right. So let me talk about your code structure. The way that you structure your code, I talked about how you order the functions in your code to make your code look nice and make it easily scannable. There's the happy path. I've used that before. I don't know if I've ever defined it, but we usually use the word happy path for the path that the code takes when everything's going right. So there's no errors and stuff like that. This is the code that is supposed to get things done. Just as a note for error handling, how much of your code is usually error handling?
Actually.
Quite a lot. Usually about a fourth of the code will be error handling for code that is well written with a lot of good error handling in it. And a fourth of the code for error handling is a lot, which can make the happy path hard to find. I've got 20, if I have 100 lines of code that I'm trying to work through, 25 of it will be error handling. I have to figure out how to get through all the error handling code and find the happy path so I can make sure that the happy path is working right, or I can modify it. Okay, so anyway, so here's some ideas on how to structure your code to make it work well. First of all, we've talked about this, so I won't put too much emphasis in this. Everything should be single purpose. That is the most critical thing for structuring your code. It's making sure all of your functions and all of your files serve a single purpose. So we often will have a whole bunch of utility functions that are just little functions that do this and that and the other that I use in a number of different places. So it was pretty common at Google to have a little function called utilities.c or JS or Java, whatever language it was. And the readability team was getting very upset with that. So we finally, if we ever saw a file named utilities.java, we would reject it outright. Say, sorry, that's not single purpose. Break it up. So we had to come up with conventions. Okay, here's all my string utilities. So that I'd have a string utilities. All right, that's more, it's at least closer to being single purpose. All right, so make sure that everything is single purpose. Okay. All right, so let me get into error handling. I talked about how much of your code is error handling, and what we would like when we're doing error handling is we find that the code is more readable, easier to maintain, and works better if you use what we call fail fast. Fail fast means I'm going to figure out what is wrong as quickly as possible and then throw an exception or somehow get out of the function. So this means, for example, if I pass an undefined into my function and it's going to blow up because of that, but it might not blow up until I call a function, call a function, call a function, call a function, and finally down here it blows up. I'm going to find an exception stack trace that points to this place clear down here that blew up, but the bug was really clear up here where the function was called. It passed me an undefined. So that is going to be a nightmare to debug. Oh, I got an undefined. Why did I get an undefined? Oh, it's up here. Where was it? This is called from 6 different places. Which one was the problem? And it's going to be very hard to figure out. So what you want to do up here is, if you know it's going to fail if there's an undefined, check for undefined immediately. Check for undefined and then throw. Okay, so that's what fail fast means. Do your error checking immediately at the top of your function and throw and get out, or whatever you're using to get out to do your error checking. Okay, that's called fail fast. All right. It's often tempting to do your error handling with if error else, if error else, if error 1 else, if error 2 else, if error 3 else, if error 4 else. So you have all these if else, if else, if else, if else, if else. Those are extremely hard to debug and hard to work with. And so they don't do the fail fast either. So let me show you an example. This is a very simplistic version of code that I ran into when I was doing a readability review at Google. Now remember, the engineers at Google are supposedly some of the best on the planet, right? It was shocking how much bad code I came across when I was doing my readability reviews. But I found one that had something like this. If it would check to see if there was a param. If so, then check to see if it's valid. If not, throw an error, else, and so on. Then it would do the happy path. And this code actually, this is a very simple version of it, because the function itself was 80 lines long, and it had just a whole bunch of if else, if else, if else, if else, checking all kinds of error conditions. And then the happy path was about 4 lines of code right here. And so it just kept getting indented, indented. It became impossible to figure out what was going on. And then finally you found the happy path. It took forever for me to go down and figure out where the happy path was. So I made it clean it up. Here's how you're supposed to clean it up. And it looked like this. This is the way you do this. Instead of all these if else's and if else's, you say, do your check, throw. Do your check, throw. And then finally, after you've done all this checking, you do your happy path. Now, as I'm scanning this function, it's very, very obvious where my happy path code is. It's just right here. It's all out down to the left, so it's nice and simple there to find. I know that these first few lines of code are error checking. So if I care only about the happy path, then I can skip all of that stuff and then look at my happy path. Okay, it's short, it's succinct, and it fails fast. So this is the right way to do it. So what I did also, I made him fix it, and we fixed it up, and we discovered a bug. Okay, so the code was so long you couldn't see it, and so nested, deeply indented, you couldn't find the bug with the way it was written. But when we did this, the bug became obvious. And the bug was, it was kind of a trivial bug. Just for example, it would have said, if not is valid, throw new error, no parameter provided. Okay, so it was giving the wrong message for the wrong check. So it was kind of a trivial bug. It was reporting the wrong error for the error that it found, but still it was a bug. And there was no way to find that bug by looking at this code. It was just too hard to read. Okay, so fail fast, do all your checking at the top, get out. That's the right way to do it. Okay, parameters. When you write functions, you have parameters. How many parameters should you have?
Like 2, 3.
2, 3. We decided at Google that if it had 5 or more, it was too many. And it was just too hard, because you write the code, you say, call foo, and you pass in all these different parameters. You get them in the wrong order, you get mixed up. Even if you're reading the code, maybe you have 2 strings and they got switched. You can't swap. It's too hard to tell. So if you have more than 5, it's unreadable. So just try to keep it to a small handful, 2, 3, 4 at the most. Okay. So, but then what do? If you look at fetch, fetch, you have to pass in a method and headers and a body and a whole bunch of other stuff that might be possible that are optional. Well, if you had fetch and it took what parameter for every single one of those, you might have 20 or 30 parameters. Well, that's unreadable. So what do you do instead? How does fetch work? How many parameters does fetch take?
Two.
Two. What are they?
The address of the API
Uh-huh.
and the header
The options.
or
The options. Okay, so it's an options object. So that's the way to solve this problem in JavaScript. It's pretty easy in JavaScript. It's challenging in some other languages. But in JavaScript, this is what you do. Suppose I have this. Oh, optional parameters make it even worse to remember how everything goes. But suppose I wrote my function like this, foo, that had 1, 2, 3, 4 parameters. Okay, that's not too terrible, is it? And then I call it like this. It's, wait, is the 73 the age or the length, hair length, and so on. It's like, and so it's very hard to figure out. So the way you do this in JavaScript is you introduce an options object. So you might say an options object. This is exactly what fetch does. And you have an options object that lays out all the different parameters you're going to get, and you just declare your function. Fetch takes the URL and then the options. So that's a good way to go. This is a good way to go too. And so now when I call it, I say, okay, I'm going to pass in the options object. I'm going to pass in the name and the height. Now I know for sure that 73 is the height and so on. So I know exactly what they are. So it makes it much, much more readable. Okay. Yeah.
just to confirm, that is you're passing the type as an object into the.
I am passing an odd parameter
Oh,
that is of this
okay.
that is of this type. Okay, you never pass types as parameters, as arguments to a parameter. Okay. All right. All right. Let me talk about commenting. I've had developers tell me that they don't need to write comments in their code because their code is self-describing. I usually politely react with them, and then I walk away and laugh because code is not self-describing, doesn't exist. I've also believed or self-documented, self-documenting is the word they use. And then I'll say, gee, my code is so well written, so clear and so obvious that you can just look at it and read it and know what it's doing. And I also usually walk away and laugh at those types of comments also. They're both untrue. Code is never so clear and obvious that it doesn't need comments. Code is not self-documenting. It always needs to be documented. Code must be documented. I actually had when I first came here, we had lint rules that said if there was comments in your code, it would give you a lint warning and you had to remove all the comments. What? How stupid is that? So we got rid of that, and then I discovered that people will comment out code and leave that in, and that's bad. Never comment out code and leave it in when you push to your repo. So that's there, and that's actually why they put the lint rule in. But it was a bad rule because comments are required and necessary in code. But there are some rules and things that you should do in order to make your code understandable and make your comments useful. The worst kind of comments, other than commented out code, that should never happen. But the worst kind of comments are the ones that tell you what the code is doing. So it says, loop through all the books. Then you'll see a for statement. Assign the book's chapter number to the chapter variable. And then you see const chapter equals book dot chapter. Okay, and so you'll see this. And so you have comments that comment each line of the code and tell you what that line of code is doing. That's terrible because I can read the code and figure that out. If I see a for loop over the books, then I know that it's looping over the books. I don't have to be told that. So you don't write comments that tell you how. So, okay. Comments instead tell you why. That's the main thing to keep in mind. Comments tell you why, not how. Okay. Now, is it possible actually to write functions that are self-documenting and are so obvious you can figure them out? Like, for example, read book, especially with TypeScript, where you can put your types in. Read book, book ID is a number, so okay, good. I pass in a book number, and it returns a book. That's pretty clear, isn't it?
Yes.
Well, what happens if it can't find the book?
We don't know where to go look. Why?
Suppose it tries to read the book and it can't find it. What's going to happen? What does it do? I don't know. I can't tell from the signature what it's going to do. What happens if the book ID is an invalid, like it's a -1? You know, what's going to happen? Is it going to return undefined? Is it going to throw? I don't know. I can't tell. So there are even something looks as simple as this. Usually, you have to put documentation on it in order to answer these types of questions. So people train our AIs with code in GitHub. Code in GitHub is some of the worst code I've ever read. So that makes me unhappy about our AI code generation because it's been trained on terrible code. It's not all of the code in GitHub is bad. There's lots of it that's great and awesome, but there's an awful lot of it that's very bad. And frequently, when I'm working with a GitHub package, I can't figure out how to call a function or understand exactly what it's going to do. What's it going to do in this edge case and that edge case and so on. And I find myself having to go in and actually dig into the GitHub package and find the code and read the code. And then if I'm lucky, I can read the code and figure out what's going to happen. I end up doing that far more often than I would like. So my rule of thumb is if I'm writing code against my own functions, and I'm thinking, oh wait, what is going to happen if I don't pass in, if it can't find the book number? I need to go read the code. So if I find myself having to go read the code, then I know, whoops, I should have documented that. So I'll then write a documentation on that function that says this is what happens if you can't find the book. Okay. All right. All right. So usually what you do, there's a special type of commenting in JavaScript called JS.doc. And most languages have something similar. I think this was actually first Java, called Java.doc. And JavaScript stole it, the idea, or made good use of the idea, and named it JS.doc. But it goes like this. You use the block commenting /* and / to do a block comment. But at the top, you do /*. And that is a special indicator to the your compiler or your IDE that this is a JS.doc comment. Then your first line, your comments here are going to be, what the function does, and then any other information you might need to put there. And then they have these things called, at this, at param. You define the book. You say, okay, this has a param book ID, and I'll say it's the book's unique identifier. At returns, I tell you what it returns. It returns a promise that resolves to the book. And then now I answer the question: what happens if the book doesn't exist? It throws. Okay, this will throw an error if the book. So this is called the JS.doc comment. And best practice is to put JS.doc comments on all of your functions. Certainly on all of your exported functions. Anything that's exported should usually be accompanied by a JS.doc comment. All right. If it's private and not exported, well, sometimes you might need to put a JS.doc comment. Sometimes you don't need to. At Google, we'd let it go unless it was a complicated function. So anyway. All right. This is a JS.doc comment. It's used. You can use it on functions and you can use it on variables. And so usually anything that gets exported, you'll have a JS.doc comment on here that explains what it is and how it works. And use these types of things. Okay. Sometimes you'll need to also describe how the function works. You usually do not put any of the how information or even the why. This is focused only on how to use it. Oh, one thing I forgot to mention If I'm trying to now call this function read book down in my IDE and I hover over read book, it will display this JS dot comment. So you've done that before. You've hovered over functions and you see the description. The IDE gets it from the JS dot comment. So it makes your life a whole lot easier if you write the code. And so you do those. So so if you're gonna, sometimes you have to also explain why or how things work. These are called implementation comments. Implementation comments do not belong in here. Implementation comments should come down in the code block down in here, and they should describe, your implementation details that you have to document for some reason.
You're gonna use this, you gotta put it at the top of the function?
Yes, you put it right above the function exactly as it's done here. So you have your function name, and then the JS dot goes right above the function. It goes, or the variable, if that's a variable, goes right above the variable. Okay. Then when you hover over it, you'll see that JS dot comment nicely formatted. All right, so again, I talked about don't explain why or how, don't explain how it works, instead tell why. So for example, why do you need to loop through the books? If it's obvious, don't say anything, but sometimes it's not obvious and you might have to say, I have to loop through all of them except the first one because that one is special case or something. Okay, so you just put a little comment about why you're doing things. That's the why of your code. All right. There are also cases where you might have fixed a bug. You write code that is a little bit unusual and you're fixing a bug. The bug's not obvious. So for example, suppose you had written set state of state plus one, but because of closure issues, this doesn't work. And you don't discover that until you're writing your code and you can't figure out why it's not working. Then you realize, oh, I have to write it back like this using the arrow function approach. And then you, oh, okay, this now works. Well, if I see your code and I see this, I don't like this approach. I think this is hard to read and ugly. So I'll probably change it to that. Well, I just introduced a button. So if you're going to do this and switch it from this to that, you should put a comment that says it must use this approach because of stale closure or whatever it is that the reason is. Okay. So those are also very good to put in. And usually you can just do those on a one line / comment. Okay. Sometimes when you do your documentation, you have to write something that's pretty long in order to describe things. And so we've just found that the best way to do that is you write a document that's in a markdown file, like the readme.md, or you'll have another thing like that. Like I will do things like my database design. So I'll do database schema.md, and I'll have a document like that, and I'll document everything in markdown in that file, and then that file gets put into the source pack or into the GitHub repo in my code, and then it gets pushed into GitHub. So now it's always there in GitHub, and then my code I'll put at the top of the file that where I'm dealing with the schema. I'll say schema is at in schema design.md. Okay, so that's a good way to do this. Sometimes when you're thinking about problems and you're thinking about what to do, then you will find that you have to consider multiple choices and try to figure out what to do and which way to go. It's very helpful if you not only document what you decided, but you also document what you thought about and rejected and why you rejected it. Because then if you're coming back and you want to say, oh, why is this architected this way? This is a mess. And then you read this and you say, why don't they do it that way? And then you read the document and you say, oh, they already thought about that and rejected it because, oops, if I had just blindly gone back to the approach that I thought was better, I would have failed and wouldn't know why. Or maybe, oh, that problem's been fixed now, so I can go to the simpler approach, so on. Okay, so just do that. All right. Okay, so that's all of my notes on all of that. I will say that when I see well-written code, I love it. I actually had a debate many years ago with when I was working at AOL with one of my friends, and we were discussing whether software is an art or a science? Any guess which side I came down on? He came down on it's a science, I came down on it's an art. So I actually believe that writing good code is it's an expressive experience, it's an artistic experience. When I open up a file and I can scan it and I see this is good code, it's like looking at the Mona Lisa, right? It's beautiful, it's awesome, and it's wonderful. It's a delight to work with. So I want your code to be as great as that. All right. So work towards making your code not only work correctly, focus first right now on getting it to work correctly.
Yeah.
After you're better at doing that, then start thinking about how do I make my code readable, understandable, easy to maintain, and a nice artistic expression. Okay. Any questions? All right, good. Go off and write great code. And